It's 1:47 a.m. You're not tired. You should be. You've been awake for 17 hours, but something is happening. Your thoughts are moving differently. Connections you wouldn't make at noon are arriving fully formed. A problem you've been carrying for days just dissolved. You feel, somehow, more like yourself than you do at any other hour. This isn't your imagination. This isn't caffeine or the quiet of the house or the particular romance of the late night. Your brain at midnight is a measurably, neurologically different organ than the one you carried through the afternoon. And once you understand what's actually happening inside it, you may never apologize for being a night person again. We are told, from childhood, that the night is for sleeping, that the productive hours are the daylight ones, that staying up late is a failure of discipline. The entire architecture of modern society, school start times, office hours, the alarm clock itself, is built on this assumption. But the assumption is wrong, or at least it's incomplete. Because the research on what the brain actually does after midnight tells a different story. Not a story about insomnia or caffeine dependency or screen addiction. A story about altered neurochemistry, loosened cognitive filters, and a mode of thinking that the daytime brain almost never enters. What follows is that story. During the day, your prefrontal cortex runs the show. This is the executive center, the part of the brain responsible for planning, inhibition, social judgment, and what neuroscientists call cognitive control. It's the part that stops you from saying the wrong thing in a meeting. The part that keeps your thinking structured, sequential, on task. After midnight, something changes. The prefrontal cortex doesn't switch off, but it quiets. Its grip on the rest of the brain loosens slightly. And what moves into that loosened space is something researchers have been studying for decades: the default mode network. The default mode network is a set of brain regions that activate when you're not focused on anything in particular, when you're daydreaming, when you're drifting, when you're lying in the dark, not quite thinking about anything. For a long time, neuroscientists considered it a kind of neural background noise, the brain idling. Then they started looking more carefully at what it was actually doing. It wasn't idling, it was integrating. A 2012 study published in the journal Thinking and Reasoning found that people performed significantly better on creative problem-solving tasks when they were tested during their non-optimal time of day, meaning night owls tested in the morning and morning people tested at night. The reduced cognitive control, it turned out, was an advantage. When the brain's filter is slightly lowered, it makes connections it would otherwise suppress. This is the mechanism behind what many writers, musicians, and artists have described for centuries without being able to explain. The feeling that the best work arrives at night. It's not mysticism. It's the prefrontal cortex releasing its grip, and the associative regions of the brain, the ones responsible for analogy, metaphor, and lateral connection, moving more freely. The neuroscientist Rex Jung calls this the difference between intelligence and creativity. Intelligence is the prefrontal cortex doing its job perfectly. Creativity is what happens when you give the rest of the brain room to operate. After midnight, you get room. Your body runs on a roughly 24-hour internal clock called the circadian rhythm. Most people know it governs sleep and waking. Fewer people know that it also governs body temperature, hormone secretion, metabolic rate, immune function, and crucially, the specific profile of neurotransmitters available to the brain at any given hour. Cortisol, the alerting hormone, peaks in the morning. It's part of why most people feel sharpest between 9 a.m. and noon. Adenosine, the chemical that accumulates the longer you're awake and creates the feeling of sleepiness, builds throughout the day and begins pressing harder on the brain by evening. But here's what's less understood. Adenosine doesn't just make you tired. In sufficient concentrations, it subtly alters the quality of thinking. It softens the boundary between focused and diffuse thought. It makes the mind more porous, more prone to wandering, and to the kind of wandering that occasionally wanders somewhere new. Meanwhile, serotonin production begins declining in the evening, while dopamine pathways remain active. The result is a neurochemical environment that is quieter, more internally focused, and more receptive to reward signals from creative or contemplative activity. The brain after midnight is, in a very specific biochemical sense, optimized for introspection. For roughly 25 to 30% of the population, the circadian clock runs approximately 2 to 3 hours later than the social norm. They're called evening chronotypes, or more commonly, night owls. And for most of recorded history, they've been told they have a problem. They don't. They have a different timing. Chronobiology, the scientific study of biological time, has established clearly that chronotype is largely genetic. The clock gene, the PER3 gene, and several others regulate the timing of the circadian cycle, and their variants are heritable. A night owl isn't undisciplined. They're running on a different internal schedule than the one society has decided is correct. What the research also shows is that forced early rising, what sleep scientists call social jet lag, carries genuine cognitive costs. When night owls are compelled to operate on morning person schedules, their cognitive performance suffers measurably. Not because they're lazy, because their brain is being asked to run intensive cognitive tasks at the biological equivalent of 4 a.m. The most creative, productive hours for a night owl aren't at 8 a.m. They're at 11 p.m., and the brain science supports them. There's something else that happens after midnight that no circadian study fully captures. Something harder to measure but impossible to ignore if you've experienced it. The world at midnight is a different place. The social obligations are over. The notifications have slowed. The weight of performance, of being witnessed, evaluated, expected to produce, has lifted slightly. And in that lifting, something in the brain that's been braced all day begins to uncoil. Psychologists have a term for the mental state that often emerges in these conditions: transient hypofrontality. A temporary reduction in prefrontal activity brought on not just by time of day, but by any condition that reduces self-monitoring. It's the same state that emerges during long runs, during flow states, during meditation. And it's characterized by the same quality: a softening of the boundary between self and thought, a sense that the thinking is arriving from somewhere slightly outside of you. Night owls have been trying to describe this for centuries, the particular quality of the late-hour mind, the feeling of access, of being closer to something true. The neuroscience, it turns out, is just finally catching up. The next time you're awake at midnight, not because you should be, but because something in you simply is, consider what's actually happening. Your prefrontal cortex is quieter. Your default mode network is moving freely. Your brain is making connections it won't make at noon. The adenosine that's been building all day has softened your cognitive edges in exactly the right direction. Hormonally, neurochemically, structurally, your brain is doing something at this hour that it genuinely cannot do at 9 a.m. You are not failing to sleep. You are not undisciplined. You are not broken. You are running on a different clock, and the hour is, in the most literal scientific sense, yours.